Thank you for coming. Thanks Open Source Connections for hosting this in Europe. It's really nice to have this kind of events. So yeah, we will talk about relevant facets. So what it is, you'll see. So first of all,
yeah. Hello everyone. Just as a nice icebreaker and to make it a bit interactive, this introduction, I would propose you a very quick poll, a couple of questions to have more information about you. So first question, how many of you are using Facets in your search engine implementation?
Okay.
Well, quite a number, everybody. Almost 99%. The second one, who's doing statistics? Who's using statistics about the Facets? Not so many. Okay. Not so many. The next one, who's using Solar? Okay. What about Elasticsearch? Okay, I think we are even. Other search technologies? Yeah, quite a few.
That's interesting.
Yeah, that's very interesting. And the last question, who's speaking French?
Okay, great.
Just bear with us because the next examples will be in French, a bit of German, English, so I hope...
We have some screenshots taken from some French websites, but yeah, you will get the idea behind the screenshots, so... Okay, you will see in this talk some similarities with the talks that you've seen this morning. So this is the first one. Trey talked about Google, which is our friend. So why this talk? As you noticed, we focused a lot on relevancy of the results. Okay, which results come first? What's on the first page? We focus a lot on making the results relevant. But yeah, in the real life, you actually also need facets and also need like a global view of your results. Who's clicking on, who's using this button? Okay. So you can try to make your results relevant, but yeah, even Google didn't succeed. So I mean, it's marketing there, but the first result might be the most relevant one, but yeah, you might not take the risk to display it.
So facets. What facets are? We are not trying to give here a very formal definition, but a rather intuitive one. Remember the examples that you had in the previous talks. You have a simple query and about TVs, for instance, and you get 4,000 results. So the first need is to be able to refine the initial query and to narrow down the number of the results. So that's one very useful case for facets. The second one, think about your favorite grocery store. You want to buy chocolate, and maybe what do you mean by chocolate? Do you mean chocolate milk, chocolate cookies, or just simple chocolate? So using facets is very useful for disambiguation. The third point, it gives a holistic view on the search results. So it gives you the big picture. You have a better understanding of your results, categories, and so on.
So eventually facets help you find that needle in the haystack more quickly, actually.
Since we are at Haystack conference. So as illustration, because pictures are more useful than any words and definitions, we take our favorite examples. You are in the grocery shop and you are looking for tomatoes. So nothing special, but on your left side of the screen you have the habit of being able to filter, to see how many categories, how many brands you have, or how many different rayons. Another example for different documents on a website, the same idea but different layout. You have the facets on the top and also typically on the left side of the screen. Yet another one, this time the facets on the right side, so nothing special. These ones are interesting because we are talking about hierarchical facets. So yes, facets could be hierarchical, respecting a certain dependency and
taxonomy.
A different taxonomy, yes. Another one which is even more illustrative, because you don't even realize at the first glance, but you have the facets inside your list of results. So right here in the middle, you are looking for bicycles, and actually with some images associated, you can filter down and be more specific on your query.
So this facet, which is on horizontal here, actually is used for disambiguation. So you search for bike, and yeah, bike, it's kind of ambiguous, so what kind of bike? Men's bike, women's bike, kids' bike.
And yet another category, we call them exotic facets, because it's a different way of presentation, the data, a different graphical representation. You can have histograms on the top, on the left side, the classical list of categories and values, a bar chart, or even more interesting, if you want to present as a map with different documents associated with different countries.
So still a facet, just a different display.
What about the mobile devices? You can still have the option of using the facets. Sometimes they are well hidden. You have a small button somewhere on the side that allows you to get to a list of facets that you have on the right side of the screen. Or yet another example, the same thing, you have to click on the button to get to the list of facets. Sometimes we talk about facets and filters, and sometimes the other way around. The boundary in between the two definitions is not very clear. So for us, what do we call facets in this example, you have different options, different values, and when one of these values is selected by the user, it becomes a filter.
So facets are like search results. It's what the engine gives to the user, and filters are what the user gives to the engine. So yeah, this is what we use as a terminology, but it's not a standard. If you notice, actually, they are called filters. We call them facets in terms of technical terms, but they are called filters for the end users.
Yeah, so why are the facets important? Nowadays, with more and more data and less space to display it. Think about mobile devices. You don't have a whole screen. You have to reduce your conversation in between the application and the user. And there are new ways of searching using voice assistants and chatbots. So even if you have the most effective algorithm to propose the best ranking model, you are still not able to show too many results. So you are limited in the space of display.
So when talking to a voice assistant, probably the first answer of the voice assistant would be a facet. It would be a question which is based on a facet. The voice assistant will actually ask you something, and it's the facet that helps it find the right question.
So already facets implemented.
Yeah, so facets are a standard feature of modern search engines today. So you have them like by default in every search engine. Lucian has great support for facets. So being Solr or Elasticsearch, you have like so in Solr you have plenty of things like branch, pivot, interval, block join. In Elasticsearch you have also similar concepts, aggregations, sub-aggregations. You have an interesting one that we'll see later on, the top hits aggregation, histograms, and even geo-grid aggregations, the ones that we use to display maps, for example.
And from the user experience point of view, as we could see in the previous examples, the display can be very diverse and very different.
Just a disclaimer for the talk. So we will show some examples of facet implementations, some challenges that we have with facets, some challenges that facets solve, so challenges, general challenges in search. And the technical details are with Elasticsearch. So the examples are with Elasticsearch. So yeah, the keynote was on Solr. this talk is on Elasticsearch, but you can do with Solr whatever we show you here with Elasticsearch. And yeah, last, we are addressing mostly the technical part and less the user experience and the graphical part, the display.
Yeah, so let's talk about the first challenge that we identified. Is related to the use case of marketplaces. So marketplaces, what is the main characteristic is that the heterogeneity of results and the possible large number of candidates for facets. You could see these examples earlier today. So we take yet another example here, looking for a USB cable. So everything looks fine. We get the results. On the left side, we have the list of facets, but actually looking closely, we can see that the last options are very far related to the initial query. So basically the last category of facets are not really adapted to.
So I will try to show you so this is just a screenshot. You will not be able to see everything, but the facet that's here, it's really not relevant for the USB cable. And I'll try to show you can you see that? Okay. That's great. So the original website for that, you will see that actually you have like plenty of facets. So look here on the left, you see a lot of facets. None of them are concerning USB cables. Okay, so this is the problem with the marketplaces. So you have plenty of attributes that are eligible for facets. So yeah, in this case they are displayed, but yeah, as you can see, they just fill the place, but they do not concern the most relevant results, which are USB cables. Okay, so just a parenthesis, just to lost the timer here, but yeah, okay.
We propose a solution. A first solution, quite simple, but could be quite effective. What if we base our facets on the top N results? So the idea is to fetch the top N results. So the first page followed by a certain number of following pages, and then retain only the facets applicable to these top N results.
LTR, learning to rank, works kind of similarly, so it rescores the top N results.
So the implementation could be very simple. You have two queries. The first one would be a term query, fetching the first N documents, let's say a maximum of 1024, because this is a limitation in terms of performances. And the second query could be a term filter based on the document's ID, followed with an aggregation.
And in this case, the aggregations, so the facets that we will see, will be the facets that apply to the most N relevant results. Okay, so most probably they will be like more relevant than the whole list of available facets. So we have a second solution, but we'll go quickly through this one because it has some drawbacks. So a second solution, maybe you might have implementations of facets like this in your search engines, is that we are using just two attributes, facet name and facet value, and we are actually bringing all the attributes within this pattern, within this data model. So for example, if you have here two attributes, which is memory and OS type, we actually model them like this: facet name memory, facet value 64 megabytes, facet name OS type, facet value Android. So you will end up with just two fields in your search engine, in Lucian, for example. There's an advantage for this. You will have less sparse indices with this modeling. So, and you have to just to pay attention, because if you have strings, numbers, booleans, you have to treat them differently and separately. So this is why you have here some treatment for strings and some treatment for numbers. Booleans also have to be treated separately. And you notice here the type nested, because this is important just to keep the connection between the facet name and the facet value. So it's important to use the nested type, which is available in Elasticsearch and in Lucian and Solr also. So with this model, the query would be something like this. So you have a first aggregation, which is on the facet name, and then inside of that you have the facet values. So this way you will have the first facets that will pop up will be those that apply to most of the results. Now, the drawback with this solution is that most of the results doesn't necessarily mean the most relevant results. Okay, so the first solution was better because it applied to the most relevant results. This one applies to the most of the results. Okay, so very quickly on this. We'll just move on. I'll take this. So the challenge number 2, it's with autocompletion. So autocompletion is nice because you can, everything which is disambiguation, you can plug it in here. So this slide is in German actually. So yeah, you get the idea. We'll not detail this one. So you see, I started to type Basque. So I have propositions here which are like facet values. Yeah, I will not dig into how to implement this. Most probably it's obvious for you. We'll take a look at this example, which is kind of more tricky. So you have like a term that pops up there, and you have filters that are suggested within the autocompletion. Okay, so in this case you search for tomatoes, and the search engine says, okay, this is kind of ambiguous. Do you want to search for tomatoes in that department or that other department? So how we implemented this kind of use case. So we actually need a second index, which is the autocompletion index. So you have the product index here. You have two products as an example. You have red tomatoes and yellow tomatoes. And you have then a suggestions index, which contains just terms, just text. Okay, so no matter where you take that text from, you can take it from, in this example, we took it from the category, but you can take it from the title, wherever you want. So we index in this autocompletion index the text and the context, where the text comes from. And it's important to index these with the update API. This is available in Elasticsearch, is available in Solr also, just in order to have the sum of all the contexts that you have for a given term. Okay, so this is the first one, this is the second one with the update API, and accessorily, so you can also increase some number here, this number here, which is called occurrences. Yeah, okay, so I'm showing on my screen, but actually. So occurrences, you can also take advantage of the update API and increase the number of occurrences just to be more relevant afterwards. So if a text appears twice, the number of occurrences will increase, so you can use that for boosting some terms. Okay, so your autocompletion index will look like this. You will have the text, which is tomatoes, and the two departments, which are context. And the query will be something like this, like just you will match the first three letters there, which is TOM. Of course, you need edge engram and stuff like that for the autocompletion part, and then you will order. In this case, we order by the number of occurrences of this term, and it allows you to display something like this. Okay, so you just type TOM, and you have tomatoes in that department. So this is the organic department. I don't know. In German, it's bio, I guess, also like in French. Yeah, so fruits and vegetables. Okay, you can even have like a service. This is a shortcut service that we implemented where you just input the text and you output the filtered suggestions like that, so tomatoes and all the filters that you can apply with your search.
So recall the example with the assistants. The problem is that you cannot have the possibility to show too many results and too much information. So the third challenge is related to how to use that with assistants and vocal. Often the response is it's actually a query, and we will illustrate that with a prototype that we implemented for voice assistant. So a simple query, as I was saying, for chocolate, the answer would be, I found 920 results for you. Then this is not useful for the user, so then the answer would be the question to narrow down this list of answers and a proposal of different options for your favorite brand.
So in this screenshot, you notice that the search engine decided that I will not take the risk to display the first one of the 920, and it answered with a facet. Okay, so which brand do you want? Okay, I don't know, how much time do we have left? Okay, I'll just show this live, so it will be more relevant, let's say. Okay, so this like voice search engine. So the idea is, I'll start from the beginning. I'll just say a cancel here. Cancel. Okay. So.
Okay, getting the test version of A2.
Okay, so.
What are you looking for today?
As I said, I'm looking for. I will not talk to it just to go for faster. We could, but. Okay, so yeah, you get the idea. I cannot respond with the 920 products, so the first answer is a facet, and this facet actually corresponds to the what you see on the screen when you search on a laptop. So I search for chocolate here, so I see here the brands. So actually, the search engine just picked up a facet and answered with that. So the challenge here is, and we don't have a solution for that actually, so it's up to you to decide to do some heuristics there or some machine learning, I don't know, just to choose the best facet that's the first answer to the user. So in this case was the brand. So yeah, if I choose the brand, then okay, so still too many results. The engine said, okay, there are 38 products. I don't take the chance to display them to you. And it suggests another facet, okay, the second facet. And in this case is the department, okay? Now again, how did you choose the department? Why the department and why not another one? Yeah, it's a challenge. Okay, so if I, hopefully if I choose this one, for example, frozen foods. Yeah, sorry, you had the errors. So I have just a few products now, and the search engine could display the results. So you noticed that in this interaction, the first two answers were facets, actually. Okay, makes sense? So yeah, let's get back to the AI-powered PowerPoint. Yeah. So as I said, the challenge is which facet to choose for the first answer, for the second answer, and so on. Yes.
Yeah. How to the fourth challenge. Relevant facets values. How to make facets values relevant in the context when you have too many results. So this is very challenging.
We actually saw this morning. Yeah.
And we had several examples in this case.
So as I said, there are similarities between this talk and some talks that we had this morning. We talked about Google, just as Trey did. This one was the talk from Jens and Arne from Auto. It's actually the same subject. We'll just show a different approach to that. And actually there's a similarity between this talk and the keynote. I'll let you find it, and we have some stickers to give away if you find it. Okay. And it's not Lucian, it's Solar Elasticsearch. Yeah. So the yeah, maybe I will show it also live. Oh no, okay. So yeah, okay. I will show it to you on the real website. So the issue that we saw this morning with Auto was that for some searches, in this case I searched for sugar, which is sucre in French. In some cases you have a lot of results. In this case we have 787, and many of them, when you search for sugar, the first thing that you really want is like sugar bags or sugar bricks, and but actually with this text sugar, you will actually bring up like orange juices, like cookies, like candies. You will bring up even yogurt or even products without sugar or sugar-free. They will pop up also. And you end up with things like this. You have like, the first results, the results are very relevant, okay? So you don't have problems with that. They are relevant. But the facets, look at the facets here. So first of all, you have the brand here. So yeah, you have some brands. The second brand here is actually an orange juice. This one is cookies. This one is orange juice also, okay? So not relevant at all. And this one is really, I mean, even more irrelevant. I searched for sugar, and I have preferences here. This one is without additional sugar, and this one is without sugar. Okay, just so these products popped up, but yeah, the facets corresponding to them are not relevant. So what you actually expect on the facets side is something like this. You have results, and you have like the brand facet, which is filtered, which is curated. So you have brands which really are brands connected to sugar bags, okay? And in preferences, for example, or labels, you have labels that are connected with sugar bags, and you don't have labels that do not correspond to what you searched. So the approach that Auto had was to filter everything, to filter the results, to filter the facet, filter everything with an automatic filter. Auto filter, yeah. And what we suggest is that you should maybe not filter the results, but just filter the facets. And this is why we have we had a question there, which was, do you monitor how facets are used in your context? So actually, when you look at the some queries that we have at Carrefour. Carrefour is like the largest retailer in France. When you search for tomatoes, 86% of products that are added to basket are come from fresh vegetables, but there are 14% that do not come from there. So yeah, we say maybe we should not filter everything, but we should content the 86% of the users. Okay, the most like the most accentuated one is the one with sugar, where 90% of the purchases come from sugar and sweeteners, which represent only 8% of the results. Okay, so for this one we could maybe filter everything. Why not? But we will still have 10% of users that will be disappointed. So yeah, the idea is to filter just one facet. So we will advance faster with this one. Yeah, I'll take this one. So it's this one is about, and it's really tricky. We don't have much time, but we'll try to show it to you. So it's about search in facet values. So the idea is, how do you bring up values that are beyond the top n facet values? Okay. So this feature is sometimes available by default in some search engines. In Lucian, it's not available by default, but you have all the tools to implement it. And it's actually quite tricky, okay? And again, I will show you some implementations. The first one is this one, okay? Like, this one is JavaScript, pure JavaScript, but you don't want to do that. So, because JavaScript, like, doesn't know everything a search engine knows. This one is good because they even did ASCII folding. For example, if I type E with an accent, it works, it still works, okay? So it's a good implementation, JavaScript implementation, but it works because I don't have many values here, so I can do that. But yeah, usually you don't want to do that in JavaScript. So here's another example. This is taken from a search engine that we developed for a modern art museum. This one is in Paris. It's called Centre Pompidou. And you have like 7,272 artists here. You don't want to do this in JavaScript, okay? So the idea is, how do you bring the next pages, and how do you bring here artists by a search in search, okay? The example I'm going to show you, the implementation I'm going to show you, it's on nationality. For example, if I type FRA, like French, I will find like all these, like 85 values that match FRA, okay? And this one is done exclusively by Lucian and Elasticsearch. And this is how we do it, very quickly, because we don't have much time. So we need a filter aggregation, the one that will do. So this is the detail for the filter aggregation. It does FRA, and it filters the values that will come after. Then we have a sub aggregation, which is the terms aggregation, which will give us the 85 values for things that contain FRA. Okay, so filter and then sub-aggregation for terms. And then, so this is the sub-aggregation for terms. And then we need the top hits aggregation in order to display the label and to display the highlighting. Because if you noticed, there was some highlighting there. Okay, and the top hits aggregation looks like this. So we have the label, which is the nationality of the artist. And we have a highlighting query, which is the same query that we used previously. Okay, so you can use this technique coupled with a real query that's on top of the aggregation. Okay, so this is how you can implement search in search and take advantage of all the features that the search engine can bring with Lucian and Elasticsearch in this case. It would be interesting to see how Solar could implement this. It's possible. And if you're going to the training tomorrow, you should ask Bertrand, who certainly will know how to do that. Okay. The last one, and yeah, we don't have much time. So.
Yeah, maybe we'll go very quick on this one. The sixth challenge, it's about unstructured data, when clustering mechanisms are the best suited to organize different groups of facets.
Yeah. So yeah, when you don't have attributes that are eligible for facets, what are your options? Clustering and entity extraction. Clustering allows you to bring up facets like this. For example, here is we use the Carrot 2 plugin for Elasticsearch, and we search for orange, which is very ambiguous, on PDF files, so you don't have like structure there. So yeah, clustering allows you to disambiguate, to bring up a facet, to show something, to refine the query. And entity extraction, so it's kind of allows to put structure into an unstructured text. For example, here, out of this text here, we extracted conference, haystack, domain search. You could bring up two facets here, the domain facet and the conference facet. And you have the values there. Okay, so yeah, this is another example of facets on PDF files, but we'll stop here. Yeah, with the conclusions. So yeah, facets are important. They should be relevant. And these are the conclusions for everything that the challenges that we saw. I'll let you just take them. And thank you.
Fantastic. So, do we have a fight between the Otto guys and the Adeline guys now? No, we're all too nice. Right, so do we have any questions?
So in your approach, you make some steps to suggest some filters in some sequence. But what if the sequence is wrong? So for example, I would like to prepare a chocolate cake. So I go to your site and type chocolate, and you ask me for a brand. I don't care, or I don't know.
So the question is about the voice search use case where the engine choose the brand facet to answer first. So as I said, we don't have a solution for that. So the facet that you choose, it's a challenge.
Yeah. So in this example, you have a cancel also button. So
yeah, the cancel is like you just make an undo, you go back. So yeah. It's this one is not really connected to the search engine, but with the workflow, with the voice workflow.
So I can
so you can
say
just
cancel
say
and
cancel
then
and you go back. Yeah.
invent something.
And you choose another
for
facet there.
cakes,
Yeah.
or what?
Actually, to be relevant in this context, you should use a lot of personalization and stuff like that. So not just like other heuristics.
Yeah,
so.
but maybe I can say all brands. I don't care in this case, so I can skip this.
You could design your search engine like that. You say, okay, this facet is not relevant for me, so I say cancel or no matter what, or yeah, you just use some keywords there and you just move on to the next one. Yeah. You could also have an implementation where the search engine displays the first one and says, well, if I'm lucky, it's the one. If not, you can go further. You could also do that. Yeah. Thanks for
Okay, do we have another question? Right, let's round of applause to our presenters.